It will just be an introductory video. I will talk about what I have planned to discuss in the upcoming some lectures on modules. And so I will begin with, of course, the definition of what's an R module, where I will always assume the ring R to be a commutative ring having the identity 1. So I will define what is a module, which is just similar to a vector space. Then I will define submodule, module homomorphism, quotient module, isomorphism theorems. These are almost similar to those that you know about vector space. So, isomorphism theorem. So these two topics will not take a lot of time. Maybe we can cover them in just one video. Then I will go to what is free module, which is also similar to the concept of basis of vector space. So yeah, then I will shift to what will be the interesting part, the exact sequences, uh, the categories and functors for one video maybe, categories plus functors. Then I will talk about some particular functor like home functor and these two. The first component is fixed and the second component is fixed. And I will talk about what are left exactness and right exactness means. And also then I will shift to some sort of what is very much important in terms of homological algebra, the snake lemma, the five lemma, and maybe then can also define the homology groups and cohomology groups. And if time permits, I will also try to cover some derived functors, namely tor and x. And also, yeah, so I forgot one thing. I will also talk about what are tensor products and how exactness behave with respect to this home functor and this tensor functor. So it will be like the video will be divided in two sections. The first one uh, in, will be of like will include the likes of submodule, isomorphism theorems, free modules, etc. And the second one will start from exact sequences, categories, functors, the tensor product, also the left exactness, right exactness, the snake lemma, five lemma, homology, and then maybe I can talk about derived functors, namely extentor and some computations, of course. So yeah, this will be my plan to cover the module theory part. The second part will be more interesting, as I say, from exact sequences. I can maybe talk about exact sequences briefly in this video. So exact sequence is so module is basically like a vector space over a field. So module is something similar, but it's over a ring, and the ring should be a commutative ring with identity. I will denote it by 1R or maybe 1. Okay. So an exact sequence is something like that. So here each mi is a module. This 0 is the 0 module, that is the singleton. And exact sequence is just a collection of these modules and homomorphism between them, such that the kernel of f, sorry, the image of f here is same as the kernel of G. So this is an example of a short exact sequence. I would denote it by SES. So it will be image of f is same as kernel of G. And in general, an exact sequence will look like uh, mi, mi plus 1 and so on, along with fi plus 1, such that kernel of fi plus 1, remember kernel of fi plus 1 is a submodule of this, and image of fi. there is again a submodule of mi plus 1. So this happen it's happening in mi plus 1. Yeah. So this is an exact sequence. And then I will talk about what is meant by left exactness, right exactness, and from there I will talk about what is the snake lemma. Then actually snake lemma is the basic ingredient to define the boundary map in homology and any cohomologic series. So I will talk about that. Those things will be more interesting. So yeah, this is my plan to cover modules. See you in those videos.